Hi, dear students. Once again, good evening to each and every one of you to our today's second live session. On behalf of the entire brilliant team, dear students, I would like to welcome each and every one of you wholeheartedly to our YouTube channel to be the part of our second live session of today of our 16 days MCQ challenge hosted by Brilliant Qatar. Success is the result of hard work, perfection, loyalty, and learning from failure. See, dear students, these are the words of Colin Powell, and these are going to be the meaningful, inspiring quote for you guys, since you guys are going to perform your life's first national level board examination in just another 5 or 6 days. Okay, so as per this quote, see, dear students, do the consistent hard work and learn from your failures, learn the lessons from your failures, and you will have to go ahead to grab your dream scores. Okay, so with this inspiring quote, we are entering into the first question of today, and your first question of today is this. See, a student has 4 resistors, 2 ohm, 3 ohm, 4 ohm and 5 ohm. She has to put one of them in place of R2 as shown in the circuit. The current that she needs in the entire circuit is exactly 9 ampere. Which of the 4 resistors she should choose? This is our question, dear students, and the options are 2 ohm, 3 ohm, 4 ohm and 5 ohm, and here we are having the circuit. Yes, everyone, please do read the question very carefully, and I hope each and every one of you are having your pen and paper with you. This needs some calculation, some mathematical calculation is needed. Everyone, please do try to do it. Okay, I also will be doing with you here. See, dear students, we are having 2 resistors in our circuit here, and that is one resistance is given, which is 4 ohm, and the another resistance is R2, that value which we wanted to find out, and the total current that we needed in the circuit is 9 ampere. Okay, so dear students, first of all we will be writing the value. See, what is the total potential difference applied in the circuit? That is 12 volt, right? So V is equal to 12 volt, right? V is equal to 12 volt. And what is needed, how much current is needed in the circuit? That is I is equal to 9 ampere. 9 ampere is the current that we needed. Okay, so to get 9 ampere current in this circuit by applying a potential difference of 12 volt, see, how much should be the resistance of this entire circuit? How much should be the resistance of this entire circuit? How can we find it? R is equal to V divided by I will be the formula for that. That is 12 volt divided by 9 ampere, which is equal to 4 by 3 ohm will be the total resistance that we needed. Okay, 4 by 3 ohm is the total resistance that we needed. Okay, now you see, dear students, what is the effective resistance of the parallel combination given in the circuit? R1 and R2 are in parallel, right? Since R1 and R2 are in parallel, what will be the effective resistance? We can write it as RP. We know the effective resistance in parallel combination, that is RP is equal to R1 R2 divided by R1 plus R2. This is the key formula that we are having with us, right? Okay, so instead of R1 we are having 4 ohm, and instead of R2 what value has to be substituted? We wanted to find that. So RP is equal to, R1 is how much? R1 is 4. So 4, then R2 is R2, we will be putting it as R2 itself, divided by 4 plus R2. Okay, so this is the effective resistance as per R1 and R2. Now you see, this both we wanted to equate, that is 4R2 divided by 4 plus R2 has to be equated with 4 by 3 ohm. Then we will be getting it like this, that is 4R2 divided by 4 plus R2 is equal to 4 by 3 will be there. Now we will have to cross it. 3 into 4, that is 12 R2 will be equal to 4 into 4 plus R2 will be having, that is 12 R2 is equal to 4 into 4 is 16 plus 4 into R2 is 4 R2, that is 12 R2. This 4 R2 has to be taken into the left hand side, so minus 4 R2 will be equal to 16. Okay, and see, 12 R2 minus 4 R2 is a 8 R2, which is equal to 16, and R2 is equal to 16 divided by 8, we will be getting it as 2 ohm, dear students. Okay, 2 ohm will be the answer. Okay, so R2 value, this R2 value is comes to be 2 ohm. We wanted to connect 2 ohm resistance instead of R2 to get a value of current 9 ampere in this circuit. Okay, how many of you got the correct answer? Yes, everyone are commenting. Yes, very good, very good. Rahul, Vijay, Samir, Sai, Ritika, Crazy Gamer. Okay, again Crazy Gamer, then Shahian, Shiraj, okay. Everyone are commenting. Very good, very good, very good. Okay, very good. Excellent. So this is the answer for that question. This type of questions, dear students, you can expect for 2 mark also. This is not only asking in the MCQ session, but for 2 mark also you can expect this type of problem solving question which needs some mathematical calculation. Okay, right. Next question. The next question for you is this. A copper wire is held between the poles of a magnet. The current in the wire can be reversed. The pole of the magnet can also be changed over. In how many of the 4 directions shown can the force act on the wire? Okay. This is a question from chapter Magnetic Effect of Electric Current, and read the question very carefully. See, related to chapter Magnetic Effect of Electric Current, I wanted to tell you something, dear students. This is a chapter which needs some imagination. Okay. That is, the magnet is oriented like this, the conductor is oriented like this, all will be given in words only. In this question it is given in picture also, but in majority of the question it will be given in words. So we will have to imagine the situation, how do these orientations has been done, we wanted to imagine in our mind. Okay, so that is actually a very important chapter which needs some imagination. Keep it in your mind, try to solve maximum number of such type of questions from the same chapter. See, look at this question. In this question, how did this magnet, this is what type of magnet actually? This is a horseshoe magnet or it is a U-shaped magnet. Okay, this is a U-shaped magnet or a horseshoe magnet. Okay, so a horseshoe magnet or a U-shaped magnet has been placed in the plane of this paper, and we placed a conductor. A conductor has been placed in between the poles. Okay, a conductor has been placed in between the north pole and the south pole of the U-shaped magnet. Okay, see, suppose if this is the orientation of the magnet, this is north pole and this is the south pole, and I am placing this current carrying conductor in between north pole and south pole like this. This is the conductor. Okay, in this way it has been oriented, right? So what are the options that I am having here? I can interchange the direction of current as well as I can interchange the direction of magnetic field also. These both the options I am having. Okay, then maximum how many number of directions we can have the force? That is actually the question is. Okay, whether it is 1, 2, 3 or 4. See, dear students, listen very carefully. Let us understand this question with bit explanation. Okay, I'm going to draw a column here, a table here, right? And see, yes, in the first column I am writing direction of magnetic field. In the second column I am going to write the direction of current. In the third column I am going to write the direction of the force. Okay, so we will have to check one by one. See, dear students, first of all we wanted to consider that the direction of magnetic field is from west to east. That is, you see, this is north pole and this is what, south pole, right? Okay, so we know that always the direction of magnetic field will be from north pole of the magnet to the south pole of the magnet, right? Okay, so since this is north pole and this is south pole, see, this is actually our geographic west and the south pole of the magnet is actually near to our geographic east, right? Okay, so we can say that the direction of magnetic field is from north pole of the magnet to the south pole of the magnet, which means that the direction of magnetic field is from geographic west pole to the, or geographic west direction to the east direction. Okay, so like that we will have to point our fingers according to Fleming's left hand rule, right? Okay, so I am going to point my pointing finger in the direction of magnetic field, that is from north pole to south pole of the magnet, that is from west to east of our geographic direction, right? So I am pointing it like this. Now suppose the direction of current is into the plane, because this current carrying conductor is placed perpendicular to the plane of the paper, right? Okay, so suppose the direction of current is into the plane, direction of magnetic field is going from west to east and direction of current is into the plane. Now you tell me, what is the direction of force according to our Fleming's left hand rule? Thumb is pointing downward. Downward means this is which direction? South direction, right? South direction. Okay, so I am going to write here west to east is the direction of magnetic field, direction of current is into the plane, and similarly the direction of force is towards south. Okay, now I have an option to change the direction of current. Okay, I have an option to change the direction of current. That is, direction of magnetic field is same from west to east. Now I am interchanging the direction of current from into the plane to out of the plane. Okay, so what happened for the direction of force? Direction of force is now upward. Upward means towards north direction, correct, towards north direction. So I'm going to write that also. That direction of magnetic field is from west to east. Direction of current is out of the plane, out of the plane. And what is the direction of force? That is towards north, dear students. Okay. Now you see what I am going to do is I am going to check by interchanging the polarity of the magnet. Okay, north and south pole I am interchanging, right? Now when I am interchanging north pole and south pole, that is this will become south pole and this will become north pole. I am interchanging. Okay, so what will happen? What will happen for the direction of magnetic field? Direction of magnetic field will become opposite from north pole to the south pole, right? Like this. And suppose the direction of current is into the plane, and what is the direction of force? Direction of force is towards north, right? Direction of force is towards north. Okay, that is east to west into the plane. Okay, into the plane. And see, direction of magnetic field is from north to south of the magnet, which means from east to west, and direction of current is into the plane. Direction of force is towards north. Okay, towards the north. And similarly, again east to west if I am taking, and current is out of the plane. Current is out of the plane. See, I am going to check that direction of magnetic field is from east to west, and direction of current is out of the plane like this. Now you see what is the direction of the force? It is towards south, right? Okay, it is towards south. Okay, it is towards south. See, now I did all the options here, dear students. Okay, see, look at this very carefully. Look at this very carefully. See, when the direction of magnetic field is from west to east and the direction of current is into the plane, we are having the direction of force south. Okay, now for the same direction of magnetic field, when I am changing the direction of current, the direction of force has become north. Okay, that is by interchanging the direction of current without changing the direction of magnetic field. By interchanging the direction of current, you know what is reversed? The direction of force has been reversed. Okay, and here also you see the direction of magnetic field is fixed east to west and east to west, but I changed the direction of current, that is into the plane and out of the plane. At that time also we are having direction of force opposite in direction, right? North and south. Okay, so by changing the direction of current, what will be changed? The direction of a force experienced by the current carrying conductor will be changed. Okay, now you see, by keeping the direction of current fixed and by changing the direction of magnetic field also will change the direction of force. Okay, see, look at this. I am keeping what constant? I am keeping the direction of current constant, that is into the plane, and you see here into the plane. Okay, but direction of magnetic field is west to east and east to west. Okay, so see, direction of force is south and north. Direction of force is reversed. Okay, and here also direction of current is out of the plane, and here also direction of current is out of the plane, but direction of magnetic field is opposite. At that time also we are having opposite direction for the force experienced by the conductor. Okay, so what you can understand from this is either by changing direction of magnetic field or by changing the direction of current, we will be able to change the direction of force. Direction of force will be reversed. Okay, that is the direction of force experienced by a current carrying conductor in a magnetic field will get reversed once we are reversing the direction of current or by changing the direction of magnetic field. Okay, and if you are changing both, that is direction of magnetic field as well as the direction of current, what will happen? No change will happen for direction of force. I'll just show you that. See, when the direction of magnetic field is from west to east and direction of current is into the plane, what is the direction of force? South. Okay, now I am going to change both the direction of magnetic field as well as the direction of current. That is, direction of magnetic field I changed from west to east to west. Okay, and direction of current is out of the plane. At that time you see in both of these cases same direction we are having for force, right? Okay, west to east into the plane, south. Here east to west, out of the plane, again south. Okay, which means that by changing both the direction of magnetic field as well as the direction of current, no change will happen for the direction of force. Okay, so here by changing direction of current or by changing direction of magnetic field, we can have maximum two directions only, that is south and north only. Okay, see, this is actually a question which need bit explanation. That's the reason why I took this much time. Please do understand, dear students. Please do understand clearly, and this type of question can be expected for your examination. Okay, so only two directions we can have, so option B will be correct, dear students. Option B will be correct. Okay, now look at the next question. Next question is this. Sheila cannot read newspaper when she hold it closer than 1 meter. The defect in her eye and the power of the lens prescribed to her is. Okay. What is actually the defect the Sheila is actually suffering from, and we wanted to find out the power of the lens that she need to correct her issue has to be found. Okay, options are myopia with a plus 3D lens, plus 3 diopter lens, myopia with a minus 3 diopter lens, hypermetropia with a minus 3 diopter lens, hypermetropia with a plus 3 diopter lens. These are the options given. Okay. See, how will you solve it? First of all, I'll just give you a bit explanation about the hypermetropia defect. Okay, this is actually hypermetropia, right? Sheila cannot read newspaper when she hold it closer than 1 meter. That is, she is not able to see the nearby object and she is able to see the farther object, which means that she is suffering from hypermetropia. Hypermetropia, how do we can draw the diagram, dear students? See, suppose this is our eyeball and we will be having our convex eye lens, right, which is our convex eye lens. This is our convex eye lens, and we will be having our corrective convex lens also here. And suppose the object that is placed at the near point, okay, the object that is placed at the near point, the light rays will be coming diverging. Okay, light rays will be coming diverging. This is which point? This is the near point. Okay, from the near point the light rays are coming diverging. And you see, when it is passing through this corrective lens, it will be converging a little. That means its divergence will get decreased, right? Its divergence will get decreased, and it will be forming exactly the image on the retina. So this is actually the ray diagram for correction of hypermetropia. And in the same diagram, see, dear students, we will be able to mark the near point of this person. Okay, how can we mark it? We will have to produce, this light ray. Okay, this light ray which is entering into our our eye lens has to be produced backward like this. Okay, so that it will be meeting at a point somewhere here, and this point is known as what? This point is the near point of hypermetropic eye. Okay, near point of hypermetropic eye. And this is what? This is the near point of normal eye. Okay, which means what? You see, this person, this Sheila, will be able to see any object which is placed at this point and beyond. Okay, this point and beyond. That is, see, this region is a red region for her. That is, anything which is placed in this red region she will not be able to see. And you see, behind that near point, you see, this entire region is a green region for her, that she is able to see anything which is kept beyond the near point of that hypermetropic eye. Okay, so this is actually diagram. This is very important diagram, dear students. Either myopia or hypermetropia is a sure question for your board examination. Now our question is not that here. Our question is to find out the power. Okay, how can we find out the power? We know that we will have to take U as negative 25 centimeter for solving hypermetropic question, and we will have to take V as what? V as negative of the far near point of the person, right? So negative 1 meter, which can be written as negative 100 centimeter it will be. Okay, now we'll have to apply in the formula, that is 1 by F is equal to 1 by V minus 1 by U. 1 by F is equal to 1 by V is how much? That is negative 100 minus 1 by negative 25, and that is 1 by F is equal to 1 by negative 100 plus 1 by 25 we will be having. Then 1 by F is equal to, we can take 100 as the LCM. This is minus 1 plus 4 we will be having. This is 3 by 100, and F is equal to what? 100 by 3, which is equal to almost 33.3 centimeter will be the focal length. Okay, so focal length of lens has been calculated. Now our question is to calculate what? Our question is to calculate the power. Okay, power is what? Power is 100 by focal length in centimeter, that is equal to 100 divided by focal length in centimeter is 33.3, which is almost 3 diopter. Okay, so 3 diopter will be the power of the convex lens that has to be used for correcting this Sheila's problem. Okay, so she is suffering from hypermetropia and she need a convex lens with power 3 diopter. So option D will be correct. Okay, everyone are commenting. Very good, very good. Yes, Arya, Samir, Rishi, Sai Ritika. Okay, Again, Crazy Gamer, yes, Shahian, yes, everyone are commenting. See, dear students, I'm, very glad to see your comments. Very, answers are correct. You are actually commenting the good answers, right? That's the reason why I'm saying I'm so glad. Okay, so you guys have started your preparation for the board examination. That's the reason why you are able to answer for the questions, right? Okay, really appreciating. Yes, next question. If the real image of a candle flame formed by a lens is 3 times the size of the flame and the distance between lens and the image is 80 centimeter, at what distance should the candle be placed from the lens? This is the question. See, dear students, first of all, let us write what are the given values. Okay, what are the given values here? See, magnification is given. The image is 3 times the size of the flame, right? Which means that magnification M is equal to 3. M is equal to 3. Okay. And what type of image is forming here? The real image. Okay, if it is real image, definitely magnification will be having a negative sign. Okay, so what is magnification actually? And before that, you see one more value is given. What is the value? 80 centimeter. What is this 80 centimeter? 80 centimeter is the distance between lens and the image. What is actually called the distance between lens and the image? That is image distance, right? Okay, so V is equal to 80 centimeter. And what will be the sign of that V? Where did this image has been formed? This image is actually formed, on the right side of the convex lens, because this is what type of image? Real image. Real image will be always forming on the right side only. Okay, so this will be plus 80 centimeter only. Now we wanted to find out what? We wanted to find out the value of U, right? Okay, so what is the formula we can use? Magnification. Magnification formula is what? V by U. V by U for lens only, right? For lens, V by U is the formula for magnification, and its value is how much? Its value is minus 3. Now we wanted to substitute these values. V is 80 divided by U is equal to minus 3. And see, dear students, take this U here and take this minus 3 down, and we'll be getting U as minus 80 divided by 3 centimeter. Okay, so the object distance or the place at which the candle has to be placed is negative 80 by 3 centimeter. Yes, yes. How many of you are commenting? Yes, yes. Many are commenting. Yes, many are commenting. Minus 80 divided by 3 centimeter will be the answer for this. Okay. In this type of question, dear students, magnification value will be given to you. From that magnification, you will have to solve it out. Okay. Yes, yes, yes. Thank you. Thank you for commenting. Everyone, keep this energy till the end of the class, and in between we'll be having the Mendi. Okay. In between we'll be having the Mendi. I will not wait for the entire class to finish, to start the Mendi. Between we will be having, so everyone stay tuned, right? Your next question is this. Two bulb B1 and B2 are exactly identical. When the key is pressed, the reading of the ammeter will remain unchanged. Second option is be doubled. Third option is be halved. D option is become 4 times. Yes, yes. Everyone give a try for this question and try to find out the answer. Everyone are having pen and paper with you. Please do try a very simple mathematical calculation to do this, so that you will be getting, even that is not needed, you can understand it, by thinking. Yes. See, dear students, this is our circuit diagram. Our circuit diagram, if it is not clear, I'll draw it once again here. Yes, this is our circuit. We will be having our ammeter here, and we will be having one bulb here, and one switch will be here, second bulb will be having here. Okay, this is B1 and this is B2. And what is given in the question? In the question it is given that both the bulbs are exactly identical. If both the bulbs are exactly identical, what will be identical for both of the bulbs? Both of them are having same resistance, right? Both of them are having same resistance. Okay, so look at this question, dear students. If this key is closed, okay, if this key is closed, what will happen? Two bulbs, both the bulbs will come in the circuit, right? Both of the bulbs will come in the circuit. If you are keeping this switch open, only B1 will be included in the circuit. Okay, suppose the resistance of B1 as R and resistance of B2 also R, because both the bulbs are having same resistance, right? Okay, so if switch is kept open, if switch is kept open, what is the resistance of the entire circuit? Resistance of the entire circuit is R only. Now how much will be the current flowing through that? See, I1 we can take. I1 is equal to V by R. I1 is equal to V by R. That will be the current flowing in the entire circuit, right? Now if the switch is closed, now what will happen for the entire circuit resistance? The resistance will become halved, right? Because one more bulb will be coming in parallel to the B1, right? When two bulbs with identical resistance are connected in parallel, what will be the effective resistance? We know the formula. Rp is equal to R by N is our formula. Okay. R by N is our formula. That is R by how many bulbs we are having here? 2 bulbs. So R by 2 will be the equivalent resistance. Okay. So I2 will be equal to same potential difference only. Potential difference we are not changing. V divided by what? R by 2 will be having. Okay. That is 2V by R, which is equal to 2I1. V by R is our I1. Okay. So what is our I2? I2 is equal to 2I1. I2 is equal to 2I1. Okay. When the key is pressed, both of the bulbs will come in the circuit, both of the bulbs will be included in the circuit, and what will be happening for the current? Current will become doubled. See, dear students, why current become doubled? Because resistance is halved. Okay, resistance is halved. We know that when potential difference is constant, electric current and resistance are inversely proportional. Okay, less is the resistance, more will be the current. That is, resistance is halved means current will become doubled. Okay, in that way you will be able to think it. So which will be the option correct? C, be doubled. The current, ammeter reading means current only, right? Okay, current will become doubled. Yes, 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 everyone are answering. Very good, very good. B, crazy gamer is commenting, you know, many comments for the same question. Yes, Himani Rao, yes, Shivan Kare, Shehyan Siraj again, yes, yes, everyone are commenting. Very good, very good. Thank you. Mayank is commenting. Yes, yes, thank you. Keep this energy till the end of the class, dear students. In between, again I am reminding you, Menti will come. Okay, next question for you is this. This is another very important type of question from chapter magnetic effect of electric current. Yes, an electron traveling horizontally enters a region where uniform magnetic field is directed into the plane of the paper as shown in the figure. Okay, what is the direction of force experienced by the electron once it is entered in the field? Yes, yes, everyone please do apply our finger rule. Which is the finger rule? That is Fleming's left hand rule has to be applied. Yes, everyone apply Fleming's left hand rule to get the answer for this question. Yes, what is the direction of magnetic field? Direction of magnetic field is into the plane. We know that if you are putting a cross, it means that something is going into the plane, right? Okay, that is whether it is direction of current or magnetic field, whatever it is. If you are putting a cross, it means that, you know, the direction of that quantity is into the plane. And if you are putting a dot which is encircled, it means that the direction of that quantity is coming out of the plane, right? Okay, so into the plane and out of the plane, you understand the symbols. These are the symbols. This is into the plane and this is out of the plane, dear students. Okay, now you see what all these three fingers are representing as per the Fleming's left hand rule. Our thumb is representing the direction of force, our pointing finger is representing the direction of magnetic field, and our middle finger is representing the direction of current. Okay, so force, magnetic field and current. Okay, force, magnetic field, current. Father, mother, child, dear students, a code you can remember. Father first letter F, force. Okay, mother first letter M, magnetic field. Child first letter C, current. Father, mother, child, force, magnetic field, current. Okay, so as per our Fleming's left hand rule, if you are applying it here, you will have to point your pointing finger into the plane because direction of magnetic field is into the plane. Okay, and similarly, what is the direction of current? What is the direction in which electron move? Electron is moving towards, you know, which direction? East direction, right? Okay, electron is moving towards east direction, so definitely the current due to that electron will be in the direction opposite to the direction of flow of electron, right? Okay, so direction of current will be towards west direction because direction of flow of electron is towards east, means direction of current will be always in the direction opposite to the direction of flow of electron. Okay, so we'll have to point our pointing finger into the plane and we'll have to point our middle finger towards west, and automatically your thumb will be pointing in which direction? This is, you know, this is which direction? This is south, right? Okay, south. Yes, yes. So the direction of the magnetic field is into the plane, the direction of the current is towards west, and automatically your thumb is pointing towards south direction, which means that the direction of force experienced by the electron will be towards south only. Yes, everyone are commenting. Very good, very good. Yes, yes, south will be the direction. Okay, so see, dear students, this is a very important type of question, different orientations you can expect. Like for example, there is a magnetic field like this, there is a magnetic field like this, okay, and in this magnetic field we will be placing a current carrying conductor like this, and what is the direction in which this current carrying conductor experience the force? We'll have to point our pointing finger towards east, because the direction of magnetic field is towards east, right? And what is the direction of current? That is towards the north. Okay, automatically your thumb is pointing into the plane, which means that this current carrying conductor will start to move into the plane, okay, because it is experiencing a force into the plane. Okay, so different orientations, like magnetic field can be given in any direction, direction of conductor or current can be given in any direction. You will be asked to find out the direction of force. Okay, this type of question you by yourself arrange different orientations and you apply the rule. Okay, apply the rule and it will be thorough for you. Okay, otherwise you will take a lot of time by applying these hand rules in the examination hall. To avoid that, you will have to make this kind of orientation, different orientations, and arrange your fingers to get the direction of force. Okay, so south will be the direction of force experienced by the electron here. Next question, see, next question. The refractive index of a medium X with respect to Y is 2/3 and the refractive index of medium Y with respect to Z is 4/3. Calculate the refractive index of medium Z with respect to medium X. Yes, 9/8, 8/9, 2/3 and 3/4. Yes, everyone please do take your pen and paper and try to solve it. Yes, I'm started to get the comments. Yes, everyone try to do it. I'll also do with you. See, dear students, what are the given values in the question? The given values in the question are the refractive index of a medium X with respect to Y is 2/3. How can I write it mathematically? Refractive index of medium X with respect to Y is NXY, right? We are writing it like this mathematically. Refractive index of X with respect to Y. Refractive index of X with respect to Y can be written as NX/NY, right? NX/NY, which is equal to 2/3, dear students, okay, which is equal to 2/3. And similarly, another value is also given in the question, that is refractive index of medium Y with respect to Z. Refractive index of medium Y with respect to Z can be written as NYZ, right? NYZ is equal to, NYZ can be written as what? NY/NZ is equal to what? 4/3. Okay, we'll be able to write it like this, right? And now what we wanted to find, calculate the refractive index of medium Z with respect to medium X. Refractive index of medium Z with respect to medium X can be written as NZX, right? NZX, and that is equal to NZ/NX. NZ/NX. Okay, we'll be able to get NX and NZ from this, right? See, from the first equation, we'll be able to write NX as what? NX is equal to 2/3 NY, right? 2/3 NY, multiply NY here, and from the second equation we will be able to get NZ as what? NZ you can take here, that is 3/4 NY, right? 3/4 NY, we will be getting 3/4 NY, okay, NZ. Now substitute these both of the values in our formula, that is, what is our NZ? NZ is a 3/4 NY and divided by NX is what? 2/3 NY. NY and NY is cancelled, so it comes to be 3/4 into 3/2, which is equal to 9/8. Okay, 9/8. Yes, who all are commenting? Yes, who all are commenting? Very good. I am getting a lot of comments for correct answer. The correct answer is 9/8. Okay, the correct option is a 9/8. See, dear students, I'll tell you once again. NXY, refractive index of medium X with respect to Y is 2/3, which is given. From that, we will be able to get NX is equal to 2/3 NY, right? NX is equal to 2/3, multiply NY here. From the second, part of the question, we will be getting that the refractive index of medium Y with respect to Z is 4/3. That is, NYZ is equal to NY/NZ is equal to 4/3. So take NZ here. So NZ is equal to, take 3 here. So 3/4 NY we will be getting from that. Okay. Then divide NZ/NX to get NZX. That is asked in the question. Yes. I hope it is clear to you, everyone. Yes. Otherwise, you see, you will have to revise it once again. If it is not clear, the explanation you will have to listen for once again, so that definitely you will be understanding. This is another 2-mark question you can expect. Okay, apart from MCQ, this question can be expected as a 2-mark question also, because it needs some mathematical calculation. Okay, so the answer comes to be 9/8. 9/8. Okay, right. board exam. Okay, look at the next question. 6 ohm and 12 ohm resistors are connected in parallel. Okay, this combination is connected to series with a 10 volt battery and 6 ohm resistor. What is the potential difference between the terminals of the 12 ohm resistor? Okay, this is the question. Options are 14 volt, 16 volt, 10 volt and 4 volt. Yes, everyone give a try to do this question. Yes, please. Yes. This is also a question which need a bit calculation, not much calculation, even you can think in your mind, you can imagine the circuit diagram in your mind and you will be able to do it, right? Dear students, I am just, for your understanding, I am just drawing a circuit diagram for this question. And how can we draw it? 6 ohm and 12 ohm are connected in parallel. So 6 ohm and 12 ohm are connected in parallel. Okay, this combination is connected to series with a 10 volt battery and a 6 ohm resistor. So I am connecting with another 6 ohm resistor with a potential difference or with a battery of how much volt? 10 volt. Okay, this is 10 volt, this is 6 ohm and this is 12 ohm and this is also another 6 ohm. Okay, so this is our combination, this is our circuit. What is the potential difference between the terminals of the 12 ohm, that is across this 12 ohm? Okay, across the 12 ohm, how much will be the potential difference? Okay, this is what is our 12 ohm. Across this 12 ohm, how much will be the potential difference? That is the question. Okay, so see dear students, in order to find out the potential difference across 12 ohm, first of all we wanted to find out the effective resistance of the circuit. Okay, then we want to find out the total current in the circuit. I'll do it step by step, don't worry. See, how can we find out the effective resistance? When 6 ohm and 12 ohm are in parallel, what is the effective resistance? 1 by Rp is equal to 1 by 6 plus 1 by 12. So 1 by Rp is equal to 12, 2 plus 1, that is 3 by 12. And Rp is equal to 12 divided by 3, which is equal to 4 ohm, right? Okay, that is the parallel combination of 6 ohm and 12 ohm will give you an effective resistance of 4 ohm, right? So this circuit I'll be able to redraw like this. This 6 ohm and 12 ohm can be replaced with another resistance that is having 4 ohm resistance. Okay, and this is another 6 ohm resistance and this is 10 volt potential difference. Now you tell me what is the total current passing in the circuit? Total current passing in the circuit will be I is equal to V by R, right? What is V? V is 10 volt divided by what is the total resistance? 6 plus 4, which is equal to 10 ohm, which is equal to 1 ampere. Okay, 1 ampere will be the current in the circuit. Now you see what is the potential difference across this 4 ohm. Potential difference across 4 ohm. Potential difference across 4 ohm will be equal to V is equal to I into R, right? Okay, what is I passing through 4 ohm? What is I passing through 4 ohm? 1 ampere. I passing through 4 ohm as well as 6 ohm is how much? 1 ampere only. So what is the potential difference across this 4 ohm? I is 1 ampere into what is the resistance? 4 ohm, which is equal to 1 into 4 is 4 volt. Okay, so across this 4 ohm we are having how much potential difference? 4 volt. Okay, see dear students, what is this 4 ohm? This 4 ohm is actually the parallel combination of 6 ohm and 12 ohm, right? Okay, which means that across the parallel combination of this 6 ohm and 12 ohm we are having 4 volt potential difference, correct? See, if I am connecting a voltmeter, if I am connecting a voltmeter where? If I am connecting a voltmeter here, if I am connecting a voltmeter here, it will be showing how much? It will be showing 4 volt. Okay, we know that if a potential difference applied across the parallel combination of two resistors, then that potential difference is applicable for what? For all the resistors, right? Parallel resistors, right? So this 4 volt is applicable for both 6 ohm as well as for 12 ohm. Okay, so across 12 ohm, how much potential difference we are having? We will be having 4 volt as the potential difference. Yes, everyone is commenting. Yes, again, Shahian is very active. Mayank is also very active, commenting for all the questions. Okay, but you check your answers. Okay, check your answers. Shahian, you check your answers. The answer is how much? 4 volt will be the answer. Okay, 4 volt will be the answer. Yes, Fatima. Okay, right. Correct answer has been commented. Yes, I couldn't see more comments. Okay. Yes. Anyway, I hope this question is clear to you, dear students. The potential difference across 12 ohm will be how much? 4 volt. And what will be the potential difference across 6 ohm? That is also how much? That is also 4 volt. Correct. Potential difference across 6 ohm as well as 12 ohm will be how much? 4 volt only. And see dear students, how much will be the potential difference across this 6 ohm? How much will be the potential difference across the 6 ohm? What is the current through the 6 ohm? 1 ampere. 1 ampere into how much is the resistance? 6 ohm, right? So across this we will be having 6 volt potential difference. Okay, so across this 6 volt potential difference, across the parallel combination of 6 ohm and 12 ohm, another 4 volt potential difference. So 6 plus 4 is how much? 10 volt. That is our total potential difference applied in the circuit. Okay, clear? I hope it is clear to you. Yes, yes, very good, very good. Yes, look at the next question, dear students. We wish to obtain an equal sized inverted image of a candle flame on a screen kept at a distance of 100 centimeter away from the candle flame. The focal length and the object distance are respectively. Yes, yes. See, imagine the ray diagram in your mind. See, dear students, ray diagrams are very, very important. Without studying the ray diagram, do not go to the examination hall. Okay, do not go to the examination hall. Total 8 plus 8, 16 ray diagrams must be thorough for you. Then only you wanted to go for examination for physics. Okay, 16 ray diagrams. That is, you know, how many ray diagrams we are having for concave mirror? For concave mirror, we are having 6 and plus 2 for convex mirror. Okay, then another 6 for convex lens and another 2 for concave lens. Total 8 plus 8, 16 ray diagrams must be there in your mind, so that you will be able to solve, you know, somewhat problems in this chapter, that is light reflection and refraction. Okay, see, we wish to obtain an equal sized inverted image of a candle flame on a screen kept at a distance of 100 centimeters. Screen is kept at a distance of 100 centimeter away from the candle flame. Candle flame is our object. Okay, remember, read the question very carefully. Do not confuse with this distance. Do not confuse that this distance is the object distance or image distance. This is not object distance or image distance. This is the distance between object and the screen. Okay, object and the screen. Okay, because this screen has been placed at 100 centimeter away from the candle flame. Okay, the focal length and the object distance are respectively. See, dear students, we wanted to get what? We wanted to get equal sized inverted image, right? Equal sized inverted image will be obtaining in case of a, you know, lens. In case of a lens, when do we are getting equal sized image? Okay, equal sized image. When do we are getting equal sized image? We wish to obtain an equal sized inverted image of a candle flame on a screen kept at a distance 100 centimeter away from the candle flame. Okay, the focal length and the object distance are respectively. Okay, see, dear students, you will have to consider that this is a convex lens. Okay, this is a convex lens. This is the case of a convex lens. Okay, okay, this is the case of a convex lens, and we are placing what? We are placing a convex lens here. Okay, imagine that this is a convex lens. Okay, dear students, this is a convex lens. Okay, in case of convex lens, we will be getting equal sized image at a 2f2 when the object is placed at a 2f1, right? So this is f1, this is 2f1, and this is f2, and this is 2f2. Okay, so when you are placing an object here at this point, it is going parallel. A parallel light ray will be going and it will be passing through f2, and another ray of light which is passing through optic center will go undeviated. Okay, it will go undeviated and it will be forming an image almost here. Inverted equal sized image will be forming at this point. Okay, now what is given here? Okay, see, dear students, you will have to consider that this is a convex lens. This is the case of a convex lens. Okay, so what distance has been given? 100 centimeter is the distance between screen and the candle flame. This is our candle flame, that is the object. This is our inverted equal sized image. So 100 centimeter is this distance. Okay, 100 centimeter is this distance. That is, you see, the distance from 2f1 to 2f2. So what will be focal length? Focal length will be, see, focal length is the distance from O to F, right? So this will be the focal length, right? This is how much? You see, this is 100 divided by 4, right? 100 divided by 4, which is equal to 25 centimeter. And similarly, what is the object distance? Object distance is the distance from object to the optic center, which is how much? Which is 50 centimeter, right? Half of 100. Okay, so what is our question? Focal length and the object distance. Focal length is how much? 25 centimeter, and object distance is how much? 50 centimeter. So 25 centimeter and 50 centimeter, this will be the correct option. Yes, this is the correct option. Yes, yes, dear students. Okay, thank you so much. See, this question you will have to consider that we wanted to get an equal sized inverted image by using a convex lens. Okay, convex lens. That part is not there in the question, but still you will have to understand that. You will have to imagine that this is the case of a convex lens. Okay, yes. Now see, we will have to enter into the Mendy that I have promised you, and after that, if time permits, we will be going into the rest of the questions. Okay, dear students. Yes, yes, everyone. Yeah, this is our, you know, Mendy frame. Yes, all of you, please do join. Please do join, everyone. With the code or the number, user code also has been given here, that is 49525044. Okay, 49525044 is the code, or else you will be able to join with our QR code. One QR code is also given here. Yes, everyone, please do join. Everyone, yes, 3 players ready. Yeah. Thank you so much, dear students. I'm appreciating your active participation in all the live classes that we have conducted. See, we teachers are actually proud of you, dear children, because you are actively participating in all the mentees. You are so much supporting us. Okay, thank you so much for your support, and we also will definitely be there with you till your board examination ends. Okay, so everyone, please do join first. 22 players are ready. As of now, 24 players are ready. Yes. See, dear students, yes, 25 players are ready. And in between that, while you are joining, see, dear students, please do hit the like button of our class if you understand the concept, and similarly, if you are thinking that the question that I have discussed is relevant, okay, such type of question, if you are expecting to come for your board examination, and also if you like our classes, please do give likes, okay, for our classes. Yes, 29 players are ready. Yes, 31 players are ready. Yes. Everyone are joining. Yeah, number is increasing. 33. Now the number is 33, 34. Yes, thank you so much, dear students. Yes, now we are having enough number of participants, and we are entering into our quiz. And your first question will appear here now. Yes, this is your first question. Yes, power of a concave lens of focal length 25 centimeter is. Yes, everyone. Yes, time is going to up. Yes. Many of you have commented the correct answer. The correct answer is come to be -4 diopter, dear students. I hope it is clear to you. Okay, those who have commented the wrong answer, don't worry. See, I'll be explaining it for you. What is the answer for this? -4 diopter will be the answer, because focal length is how much? Focal length is equal to 25 centimeter, which will be having a minus sign since it is concave lens, right? Okay, so what is the equation for power? P is equal to what? 100 divided by focal length in centimeter. Okay, this is equal to 100 divided by -25, which is equal to how much? -4 diopter will be the power. Okay, -4 diopter will be the power. Yes, congratulations to all the students, those who have given the correct answer. Yes, let us go to the next question, dear students. Yes, your second question is appearing here right now. What happens to the image distance in the eye when we increase the distance of an object from the eye? Yes, everyone. Yes, time is up. Yes. Majority have made the correct answer, but some of the students, some large in number. Here the wrong answer is large in number, right? Increases have been written by 12 number of students. See, dear students, it doesn't change actually. Okay, it doesn't change. What is actually image distance? Image distance is the distance between lens and the image, right? It is the distance between lens and the image. See, in case of our eye, lens is actually our convex eye lens, right? And what is the image? Where is the image formed? Image is forming in our retina, correct, retina. So the distance between our convex eye lens and the retina is not at all changing, which is almost equal to the diameter of our eyeball, right, which does not change at all. But what is changing? What is changing? The focal length of our eye lens will get changed depending upon the object distance, right? So according to the object distance, the focal length of our eye lens, which means the curvature or the thickness of our eye lens, will get adjusted. That is, when we are looking at nearby object, you see what will happen, the curvature or the thickness of our eye lens will get increased, and when we are looking at farther object, the curvature or the thickness of our eye lens will get decreased. Okay, so accordingly, the eye lens focal length will get adjusted to form the image exactly on the retina. Image distance doesn't change. The distance between lens and the retina doesn't change at all. Okay, so the correct answer is doesn't change. Don't worry, few number of students have made wrong answer in this. Don't worry, we'll be having next question here. Next question for you is yes. Next question for you is appearing here right now. Yes, energy consumed by an electric motor of power 1500 watt in 2 hours is a very simple calculation. Okay. Yes, time is up. Yes. Majority have commented 3000 kilowatt hour. 3000 kilowatt hour. But yeah, few students have commented 3 kilowatt hour. 3 kilowatt hour is the correct answer, dear students. See, look at this. I'll explain it for you. See, what is the unit in which options are given? Energy options are given in kilowatt hour, right? So we wanted to find out the energy in kilowatt hour. Okay. See, we will be able to calculate energy in kilowatt hour by multiplying power in kilowatt with time in hour. Okay, don't forget the formula for energy. What? The formula of energy in kilowatt hour is what? Power in kilowatt multiplied by time in hour. But you will be able to get energy in joule also. In joule, if you wanted to get energy, multiply power in watt with time in seconds. Okay. So in these two ways, you will be able to calculate energy consumption. One is in kilowatt hour, which is the commercial unit. Okay. In order to get the energy in commercial unit kilowatt hour, you will have to multiply power in kilowatt with the time in hour. If you wanted to get energy in joules, joule is the SI unit of energy. If you wanted to get energy in joules, you will have to multiply power in watt with the time in seconds. Okay. This type of question we did in the last live. My last live in electricity chapter, I did it. Okay. See, energy in kilowatt hour, we will have to find out. Power in kilowatt. See, 1500 watt is this. 1500 watt is, okay, the unit of power. 1500 watt means how much will be the kilowatt? 1500 divided by 1000 we will have to do. Okay, 1500 divided by 1000 we will have to do. So we will be getting 1.5 kilowatt. Okay, 1500 watt is how many kilowatt? That is 1.5 kilowatt multiplied by it is operated for 2 hours. So into 2 hours, like this we will have to do. 2 into 1.5 is how much? That is 3 kilowatt hour. Okay, 3 kilowatt hour will be the answer. So instead of simply multiplying time and power, you just think about the units. Okay, if you wanted to get energy in kilowatt hour, multiply power in kilowatt with time in hour. If you wanted to get energy in joules, multiply power in watt with time in seconds. Okay, if you wanted to get energy in joules, see dear students, you will have to multiply 1500 with not 2 hours. 2 into 1 hour is 3600, right? Okay, so 1500 watt into 7200 you will have to multiply, so that you will be getting energy in joules. Okay, but here you will have to get energy in kilowatt hour, because all our options are given in kilowatt hour. Okay, so this is the way in which we are solving this question, and we are entering into our next question. See dear students, next question for you is this. I'll display to you. Yeah, yes. Yes, this is our next question. Yeah. This is the electron, okay? This is the electron. And this is magnetic field. Magnetic field. Yes, everyone. comment. Sorry, give your answers. Yes, majority have commented correct answer for this question. Yes, I do appreciate you, dear students. 11 students, 11 have given the correct answer. Yes, correct. Okay, that is out of the plane, right? Because in that case, electron was moving upward, right? Electron was moving upward, and the direction of magnetic field was towards east, right? Magnetic field, that is B, was towards east. So direction of electron is towards upward, means towards north only. So we will have to point our middle finger towards south, right? Because direction of current will be opposed to the direction of flow of electron, right? So like this we will have to point, and your thumb is pointing out of the plane. Very good, excellent. Yes, let us go to the next question, last question. Yes, our last question is this. Yes, here also majority of the students have given the correct answer. That is 5 will be the magnification, right? 5 will be the magnification. How do we are getting 5 as the magnification? Those who have given the incorrect answer, I'll just explain it to you. See, dear students, this is a magnifying lens. Magnifying lens means which lens? Magnifying lens means a convex lens. Okay. An object is placed at 9 centimeter. 9 centimeter. See, this is our convex lens, and we will be placing an object at a 9 centimeter from the optic center. This is 9 centimeter. So U is what? U is minus 9 centimeter. Okay. And what type of image is formed? Virtual image. Virtual image is formed 45 centimeter from the lens. Okay. Virtual image will be forming on which side of the convex lens? In case of convex lens, the virtual image will be forming on the left side, right? Okay. So V will be how much? V will be equal to negative 45 centimeter. V will be equal to negative 45 centimeter. And what is the formula for magnification? M is equal to V by U in case of lens. That is equal to V is how much? Negative 45 centimeter divided by negative 9 centimeter. Negative and negative will become positive. 45 divided by 9 is 5. Okay, 5. Centimeter and centimeter also will be cancelled, and magnification is a quantity which doesn't have unit, right? Can you tell me another quantity which doesn't have unit? That is refractive index, correct? Refractive index and magnification doesn't have unit, it will be having a number only, correct? So minus 45 divided by minus 9 is come to be 5. 5 will be the magnification here. Okay, okay, dear students. Okay, thank you for participating in the Mendy. Yes, our leaderboard is coming here. Have given with the highest score. Yes, Veniga, I do congratulate Veniga for attending this quiz and for scoring the highest score. And I'm not forgetting the name of the other students, second and third prize, Nebiha and Niranjan. Okay, ESM. Okay, then Hrudul, Zainab, Samir, Sirin. Okay, I'm not able to read. Yeah, Sirin. Yes. Okay, I'm congratulating each and everyone who have joined this Mendy quiz, and we'll be coming in the coming days also with some interesting questions, and still we'll be having 2 more sessions for physics, and some interesting important questions will be displayed, and you guys can enjoy that. Okay, so study well for your examination, keep practicing. Okay, till the end of the board examination, you see, keep on practicing and do the hard work as I said in the beginning of the class, dear students. Okay, I wish you all the best for your studies, and we'll be seeing with our next class. Thank you for joining. Bye, good night and take care.
Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT,
J,
SAT, or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.